It's 7:30 in the morning. Prep starts in 30 minutes, but as soon as you open the walk-in cooler door, the warm air hits you. Inside, thousands of dollars of leafy greens and premium meats are already ruined. For decades, the restaurant industry has relied on a remarkably low-tech defense against this scenario. A staff member walks around the kitchen with a paper clipboard, manually spot-checking and logging temperatures every few hours. That manual method requires absolute human consistency, and it leaves a massive vulnerability. The moment the kitchen closes and the last employee locks up, the business enters a completely blind period that lasts all night. By the time someone picks up that clipboard again in the morning, they aren't preventing a disaster. They are simply documenting a total inventory loss that has already happened. Even if a manager's log shows a perfectly safe daily average of 36 degrees, the product sitting on the shelf might be actively rotting. This chart shows exactly how that happens. A simple arithmetic average smooths out the dangerous extremes. If a door is propped open during a chaotic dinner service, or a compressor stalls for an hour before recovering, the resulting spike gets buried. The math yields a flat, comforting daily average line, hiding the crisis. But biological damage does not obey simple math. When heat penetrates the cooler, bacterial colonies multiply, and enzyme activity accelerates. When the cooler eventually drops back down to a safe temperature, that biological damage does not reset or reverse. The math average might tell you the equipment recovered, but it is entirely incapable of measuring the unrecoverable biological burden absorbed by your food. The BT tracker system solves this disconnect with continuous automated monitoring that reads a cooler's environment based on biology rather than basic arithmetic. The first critical metric the system tracks is mean kinetic temperature, or MKT. Instead of treating every data point equally, MKT applies exponential weight to warmer readings. Since biological spoilage speeds up exponentially with heat, this calculation precisely mirrors how food actually degrades. We can see this through a gap analysis chart comparing two environments. In a steady, healthy cooler, the average and MKT remain identical. But in a danger state, where a brief heat shock occurs, the MKT line diverges sharply above the simple average. Measuring that gap strips away the illusion of a safe daily average, revealing the actual cumulative heat debt that drives microbial bloom and texture damage in your inventory. Heat is only half of the spoilage equation. The second invisible threat in the cold chain is the interaction between temperature and relative humidity. This relationship is measured by vapor pressure deficit, or VPD. VPD calculates the absolute drying power of the air. High VPD acts like an aggressive dry sponge. It pulls moisture straight out of fresh produce, leaving you with limp, wilted vegetables, and causes rapid freezer burn in frozen goods. Conversely, a low VPD environment is like a wet sponge. The air is too saturated for evaporation to occur, causing water to pool on surfaces. This environment triggers rapid outbreaks of bacterial slime and gray fuzz, known as botrytis mold. If your monitoring system only tracks simple temperature, the absolute drying power of the air goes entirely unregulated, leaving your kitchen blind to a massive driver of food loss. Operating a kitchen during a dinner rush leaves zero time for managers to manually calculate vapor pressure deficits or chart kinetic temperatures. To solve this, the BT tracker system synthesizes these complex metrics into one clean output, the Microbial Growth Risk Score, or MGR. This 0 to 100 index is generated by automatically summing four distinct penalties: pure temperature danger, humidity interaction, MKT deviation, and thermal instability. This chart shows the BT tracker dashboard in action. Because the system runs these calculations continuously, managers simply track this single dark red microbial growth risk line as it surges in response to a significant temperature spike. It takes layers of complex atmospheric science and converts them into an immediate, highly accurate representation of the biological stress placed on your inventory. Now, let's revisit that opening scenario. The restaurant is closed, and at midnight, a walk-in freezer compressor begins to stall. But this time, there is an automated intervention. As the kinetic temperature begins to spike, the system registers the rising microbial growth risk score and sends an immediate, real-time alert directly to the owner's phone at 2 in the morning. That early warning provides the exact window of time needed to dispatch a technician and relocate the perishables before the morning shift even clocks in, saving thousands of dollars in product. And because this highly accurate data is continuously logged and archived automatically, generating paperwork for health department inspections and maintaining HACCP compliance requires zero manual effort. By replacing the blind spot of the paper clipboard with automated biological intelligence, the BT Tracker system protects your margins, guarantees your food safety, and returns your peace of mind.